Hello everyone, I am Vinay Kumar M. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So in my previous video, I was actually discussing the chapter 8 of 9th standard. That was on force and laws of motion. By now I have covered most of the concepts which are there in this particular chapter. And in this particular video and in my next videos, we will be discussing the exercises which are there in this particular chapter. Coming to the first question, here they have asked there is an object and that particular object experiences net zero external force. So here one thing you should remember, net zero external unbalanced force. This is what they have given here. So here let us consider a particular object which is lying on a particular road, and object is not at all experiencing any kind of external unbalanced force. So when there is no external unbalanced force acting upon this particular object, that means an external unbalanced force which is zero, which is equal to zero, then this particular object will have inertia, because according to Newton's first law of motion, if there is no unbalanced external force acting upon an object, then object will continue to remain in whatever state it is in. So here in first case, if there is no net unbalanced external force on this particular object which is at rest, then this particular object continues to remain in rest. And in second case, if this particular object is moving with certain amount of constant velocity, and again net unbalanced force, external unbalanced force is zero, then if this net unbalanced external force is equal to zero, this particular net unbalanced force, then this particular object continues to remain in that particular constant velocity. Or in first case, if the object was at rest, then it continues to be at rest. So whatever the state of motion of that particular object is there, that state of motion will be continued. But here in the question they have given net zero external unbalanced force. That means here there is no external unbalanced force, or that external unbalanced force is equal to zero. So that means either this object, if it is at rest, it continues to be at rest, or if it is moving at constant velocity, then it keeps on moving in that particular constant velocity. That means that state of motion is not changed. So coming to the second part of this particular question, here state the condition that must be placed on in order to this particular object to remain in the state of motion. So here when a particular object is traveling, in the second case, if you consider this particular second case, in second case object is moving with constant velocity. That means this particular object is already in motion. So that means if the net external unbalanced force is zero, then this particular object which is moving with constant velocity will keep moving on in that particular constant velocity. So that means this object will continue to be in the state of motion. So here they have asked, is it possible for the object to travel with a non-zero velocity? So what do you mean by non-zero velocity? That means this particular object will be having certain amount of velocity. So when a particular object is having constant velocity, then it will not change its velocity and it keeps on moving in that particular constant velocity, because the net external unbalanced force is zero on this particular object. So in this particular question, the condition which should be there for this particular object is object should be moving with constant velocity. So if it is moving with constant velocity, then if net external unbalanced force is zero, then it keeps moving in this particular constant velocity only. So that means it is moving with a non-zero velocity. So coming to the second question in this particular exercise, here they have given if a carpet is beaten with a stick, then dust comes out of that particular carpet. What is the reason behind this? Here Newton's first law is applied. Here Newton's first law is applied, because if you assume this as a carpet, so let us assume this as carpet, and on this particular carpet small dust particles will be attached like this. So if small dust particles are attached like this, and if this particular carpet is at rest, then suddenly when you beat this particular carpet with a certain amount of force, then you are supplying some amount of unbalanced external force so that the rest state of this carpet will be changed. But the dust particles which are lying on this particular carpet will be having certain amount of inertia. So here this particular dust particles will be having inertia. So dust particles will have inertia, and when there is an external force applied, so this is an external force which is applied on this particular carpet, so this carpet will change its rest state and it comes to state of motion. But dust particles, due to their inertia, they continue to remain in rest, and hence we observe that dust coming out of the carpet. That means when you hit the carpet will move from its position like this, and the dust particles which are stuck on that particular carpet due to inertia which is there in that particular dust particles, they will not move along with the carpet. Hence, because of this inertia, because of this Newton's first law, when you change the state of motion of carpet, immediately the change in state of motion for that dust particles will not occur because of inertia. Hence dust particles will be separated from the carpet. So more you go and hit that particular carpet, then more and more dust particles will come out, because whatever the dust particles which is there on that carpet is having inertia will come out of that particular carpet. That means here you are actually changing the state of motion of carpet. So from this position the carpet has moved. That means it has come to the state of motion from state of rest. But the dust particles which were at the state of rest will continue to remain in state of rest, and when carpet is moved, that means when carpet is in motion, the dust particles will still continue to be in rest because of inertia, and it appears that dust particles are moving out of the carpet. Coming to the third question, here if a particular bus is actually traveling, so let's assume this as a bus, and if this bus is traveling on a particular road, here the objects which are kept on top of this particular bus should be tied with rope like this. Why it should be tied with rope? Why it is suggested to tie the objects placed on this bus with a rope? Because when bus is traveling on a road, suddenly if something comes, then driver has to apply brakes. And when the road is clear, then driver has to accelerate the bus. So in the process of acceleration and in the process of braking, that is when you apply brake, deceleration is taking place. So that means here constantly acceleration and deceleration is happening when bus is moving on the road. Constantly the state of motion is changing, and the object which is kept on this particular bus, so let's say this is an object which is kept on this particular bus, and if it is not tied with any rope, then this object, if a particular bus is traveling at 30 km per hour speed, suddenly if driver accelerates the bus to 50 km per hour, then suddenly the state of motion of this bus will be changed, but this object which was lying on this will be experiencing this 30 km per hour speed initially, and suddenly when the speed of bus is increased to 50 km per hour, because of the inertia present in this particular object, that is resistant to change in state of motion, because now state of motion of the bus is changing from 30 km per hour speed to 50 km per hour speed. So that particular change in state of motion is resisted by the object due to inertia present in this particular object. Due to that resistance, this particular object will move back, because initially it was actually in a state of motion where the speed was 30 km per hour. Now the bus speed has increased to 50 km per hour because the inertia present in the object, because there is an inertia present in the object will resist to that change in state of motion, and it keeps continuing in 30 km per hour speed because of inertia, because it is resisting to change its state of motion. Hence it will move backward. And if a particular person applies brake, in the second case, if this particular driver applies brake, then suddenly this 30 km per hour speed will be reduced to 10 km per hour. So let us assume So if a particular bus, in this bus, if driver applies brake, then 30 kilometer per hour speed, if it reduces to 10 kilometer per hour, but the object which was lying on this particular bus will be still having motion which has 30 kilometer per hour speed, because the change in state of motion is resisted by this particular object. This object will move. That means whenever there is deceleration happening in the bus, object which is kept on the top of bus will move forward, and whenever acceleration is happening, that object which is kept on the bus will move backward because of the inertia which is there on that particular object. So to overcome that inertia, to make that particular object also move along with the bus, so in order for that object to adjust for the state of motion, we have to tie that object with rope along with the bus. So when that object is tied tightly with the bus roof, then whenever there is change in state of motion, because of that tight tying of object with the bus, the object will also change its state of motion along with bus. That's why it is always suggested to tie rope for the object which is kept on the top of moving bus. So all this explanation you can actually write in your own words for this particular third question. Coming to the fourth question, here there is one more situation given. There is a ground. On this particular ground, a batsman hit a particular ball. So people are playing cricket and batsman has hit that particular ball. So that ball falls on the ground, and because it has certain amount of velocity, it will move to a certain distance, and after traveling certain distance, this ball comes to rest. Why this particular ball is coming to rest after traveling a certain distance on the ground? So this is the question, and they have given certain options. Here option C is correct, because here in option C they have given there is an opposite force on the motion of the ball. So there is opposite force on the motion of the ball. Because here there is opposite force. What is the opposite force? Ball is rolling on the ground. When a ball is rolling on this particular ground like this particular ground will apply opposite frictional force for this particular ball. So there will be certain amount of frictional force which is applied by the ground on this particular ball. So because of this opposite force, because of this frictional force between ball and the ground, which is acting opposite to the direction of motion. So this is the direction of motion. So this is the direction of motion, and this frictional force is acting opposite to this particular direction of motion. Because of this opposite force on the direction of motion of the ball, this ball, after traveling certain distance, it comes to rest on the ground. So that's why option C is correct for this particular fourth question. So coming to the fifth question, here there is a slope, and on this slope a particular truck has been placed. So this truck, initially it will be at rest. So with a certain amount of acceleration, this particular truck will move downwards on this particular slope. So initially it was at rest, now it is in motion and it is accelerating downwards, and it has covered 400 meters. So let's say this particular distance as 400 meters in 20 seconds. So after accelerating for 20 seconds, it has covered 400 meter distance. So that means here distance S is given as 400 meter, and they have also given time, that is 20 seconds, and here initial velocity is 0 because truck was initially at rest. Now you have to find out what is the acceleration. We all know equations of motion. In that, if you consider the second equation of motion, that is S is equal to ut plus half at square. Here initial velocity is 0 because truck has started from its rest position. So initial velocity is 0. So this entire term will become equal to 0. So S is equal to just half at square. Now you have to find out what is the acceleration. Here they have given distance. Distance is 400 meter. So distance is given in SI units. So directly you can substitute 400, and time is also given in seconds, that is in SI units. So here directly you can substitute this 20 seconds in this particular time. So acceleration A will be there and 20 seconds is there, that is time. So 20 square, because here half AT square is there. So T square means it is 20 square. So what is 20 square? 20 square is 20 into 20. 20 into 20 is 2 2s are 4 and 2 zeros is there. So 400. So 400 is equal to 1 by 2 A into 400. Now if you bring this 400 to LHS, then this particular 400 will go to denominator, because in the RHS it is in multiplication. So when it is brought to LHS, it will go to the denominator. So that means you are dividing the LHS with 400. So that will be equal to 400 by 400 equal to half into acceleration. So now if you bring this 1 by 2 to RHS, 2 will go to numerator, 1 will come to denominator. So here 400 ones are 400, 400 ones are 400. So 1 into 2 by 1 is equal to A. So therefore acceleration is 2 meter per second square. So here at acceleration 2 meter per second square, it is coming down. That particular truck is rolling down with acceleration 2 meter per second square. So now based on this data, you should find out the force of this particular truck. So now M of this particular truck, that is mass of this truck, is 7 tons. So here they have given 1 ton is equal to 1000 kg. So you should remember 1 ton is actually equal to 1000 kg. So 7 tons will be equal to, so 70 I will write. So 7 tons will be equal to 7 into 1000 kg. So that is equal to 7000 kg. So now you have mass in SI unit, that is 7000 kg. So now we have got mass of this particular truck as 7000 kg, and we have calculated acceleration of this particular truck, that is 2 meter per second square. So now you can calculate force, that is equal to mass times acceleration. So F will be equal to 7000, because it is in SI unit, I am directly substituting 7000 into 2. So force is equal to 7 2s are 14. So 3 zeros is there. So 14,000 SI unit of force is Newton. So 14,000 Newton is the force of that particular truck. Coming to the sixth question, there is an ice glacier, and on this ice glacier a stone is thrown, and this particular stone initially it will be having velocity 20 meter per second. So here they have given initial velocity, that is equal to 20 meter per second, and the mass of this particular stone is equal to 1 kg. So mass of stone is 1 kg and it is traveling horizontally on this particular ice glacier. So here it has come to rest after traveling 50 meter. So after traveling 50 meter distance, this particular stone has come to rest. So now the stone is at rest, that means its final velocity is 0 meter per second. And the distance covered by this stone is 50 meter and mass is 1 kg and initial velocity is 20 meter per second. Here they have asked to calculate the force of friction between stone and that particular ice. So here frictional force is opposite to the direction of motion of this particular stone, which we actually discussed in fourth question. The similar case was discussed in fourth question. So here frictional force is in opposite direction to the direction of motion of this particular stone. Hence that stone has come to rest. That means its velocity has reduced to 0 and its initial velocity was 20 meter per second and it has traveled 50 meter and the mass is 1 kg. Now you have to calculate that particular frictional force which was opposed to the direction of motion of this particular stone by the ice. So now based on all this data, you have to calculate force, but in order to calculate the force, here mass times acceleration is required. So in order to calculate this particular force, which is opposing the direction of motion of this particular stone, we want mass and acceleration. So we have mass, but we don't know what is the acceleration. So in order to find out the acceleration, we can use the first equation, that is v minus u divided by t. But here we don't know what is the time. They have not given time, but they have given the distance. So according to second equation of motion, distance is equal to ut plus half at square. So now based upon this particular equation, you can calculate the time. So what is the time? So now I'll write the equation one more time, that is S is equal to ut plus half at square. So in the place of acceleration, we can write this v minus u divided by t. So S is equal to ut plus half in the place of acceleration. So let us say this particular equation as equation 1 and this as equation 2. So here what I am doing is I am substituting equation 1 in equation 2. So what is equation 1? Equation 1 is A is equal to V minus U by T, and equation 2 is S is equal to UT plus half AT square. So in this equation 2, I am substituting equation 1. That means in the acceleration, I am substituting V minus U by T. So in the place of acceleration, I am substituting V minus U by T into T square is there. So here 1T gets cancelled and 1T gets cancelled. So S will be equal to U. I can take T common in both of them. Before taking common, I'll write the equation. So here S is equal to UT plus half V minus U by U into T. So here T is there in both the terms. So we can take T as common. So S is equal to U plus half V minus U. So we can put one big bracket for this, and T we can write outside. So we know what is the distance. So what is the distance? Distance is 50 meter, which they have given in SI unit. So what is initial velocity? Initial velocity here is 20 meter per second plus half. What is final velocity? Final velocity is 0 minus 20 meter per second is the initial velocity. This total is multiplied with time t. So now 50 is equal to, here if you solve this, it is minus 20 by 2. Minus 20 by 2 is minus 10. So 20 minus 10 will be there into time t. So 50 is equal to 10t. So now if you bring 10 to LHS, then that will be equal to 50 divided by 10 is equal to t. So here we have 50 is equal to 10t. So 50 by 10 is equal to t. So t is equal to, here 0 gets cancelled with each other. So 5 seconds. So now we have got time t. So now we can calculate the force. So now we have got time is equal to 5 seconds, and we know the mass of this particular stone, that is 1 kg. So now you can calculate the friction force applied on this particular stone by the ice. So that force, let us call it as capital F itself. So that is equal to mass times acceleration. So acceleration you can write it as V minus U by T. So now we know what is time. So F is equal to mass is 1 kg, V, that is velocity, is final velocity is 0 minus initial velocity is 20 divided by time is 5 seconds. So now we have minus 20 by 5. So that is 5 ones are 5 fours are. So F is equal to minus 4 Newton. So always remember, this minus indicates that the force is acting opposite to the direction of motion. So when stone is traveling on that particular ice glacier, at that time ice glacier is applying frictional force opposite to the motion of that particular stone. So that's why this negative symbol is coming out here. So the frictional force is equal to minus 4 Newton. So here minus indicates the force is opposite to the direction of motion of the stone. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.